Hey guys, let's now transition into 9.4 here and look to graph some of these, taking essentially motion on the unit circle and then translating it over either time or distance, okay? Looking at your height of your wave as a function of either distance or time. Okay, so identify the amplitude and period of g of x equals 3 sine x. Then graph and describe the function as a transformation of sine x. Well, if I'm going to graph sine x, let's deal with this one first, our parent. Well, my amplitude is 1. The absolute value of 1 is 1, right? That's what's there in front of the sine. And then our period is 2 pi over the absolute value of b, but in this case b is just 1, okay, absolute value of 1, so that's 2 pi. Okay, so if this is 0, x, y, and again, remember we can look at x as distance or as time, depending on our situation. Okay, but again, that's period is length is 2 pi. Okay. And then what did I do? I broke it into 4 parts, 4 equal parts. I divided 2 pi into half here, and then into half again. Okay, and let's call this let's call this 1 and negative 1. Okay, and then what did we do? Well, we take our period and divide it in how many parts? Divide it in 4 parts. You got it. So that's pi halves. That's how much I'm going to add to my starting location. Well, my starting location is here at 0, so 0 plus pi halves is pi halves. And pi, then I add that same amount to that location, so pi halves plus pi halves is 2 pi halves or pi. Okay. And then again, I'm going to add pi halves again to it. So that would be 2 pi halves plus pi halves, 2 over 2, which would be 3 pi halves. And then 3 pi halves plus pi halves is 4 pi halves, which is 2 pi. Okay, so I've got all my intermediate locations now. And then I want to evaluate. So y equals the, and of course we know we start at 0, 0 for a sine. Okay, so let's do pi halves. Sine of pi halves. And remember, this is where you then go to the table. X, y, pi halves, pi, 3 pi halves, and 2 pi. And of course, we might even begin with 0 if we weren't sure where we started, okay? Okay, so then the sine of pi halves, I would think on the unit circle, well, pi halves is a 90, sine corresponds to y, so that should be 1. And how about the sine of pi? Well, the sine of pi on the unit circle, sine is y, and that's at 180, so I know that's 0. And then negative 1, and so on. Okay? Okay, so then I plot those locations. And then I want to draw my graph. And remember, it's sinusoidal. It's going to make a waveform. Okay. So the time it takes, or the distance it takes to go to make one period is between 0 and 2 pi. So 2 pi, and it makes one cycle or one wavelength. Okay. Okay, so that's our parent, sorry. Let's erase and graph now 3 sine x. Okay, for 3 Okay, well, this has an amplitude. The absolute value of 3 is 3. And a period of 2 pi. Well, 2 pi over the absolute value of b, which is the absolute value of 1, remember, which is found right there in front of the x, which again is just 2 pi. Okay, so then we do the same process, 2 pi divided by 4 pi halves, and we add that from our starting location here of 0. 0 plus pi halves is pi halves. And then we do the same process we did on the last one, same location, okay? Same intermediate places. Then we're going to evaluate those. And we already know at 0 we're at 0. Let's do pi halves. So y equals 3 sine of pi halves. Well, the sine of pi halves we said before was 1. Then multiplied by that 3 is 3. And then again we said the sine of pi was 0, 0 by anything. 3 pi halves, when we evaluate it, would be negative 3. So when I plot those locations, let's call this up here 3, and down here negative 3. Okay, again. So same process as last time, same period length, because we just have what's called an amplification here. We've got an amplitude change. And then I'm going to draw my shape. So it's a waveform just like our parent. And sorry, this should come up a little more, like probably there through there. Okay. It's a waveform over the same period as our parent, except it's amplified by a factor of 3. It's got a vertical stretch of 3. So what that did is it modified the amplitude to, it went up to 3 instead of 1 and down to negative 3 instead of negative 1. But it went through 0, 0. It went through 0 at pi. Sorry, that should go right through there. That's a little off there. Should go through that location too, okay? All right, and so, and the transformation again here is a vertical stretch of 3. So the period length is the same, and it's just vertically stretched by a factor of 3. So it's a sine wave, starts at 0, 0, opens up if it's positive like it is. Okay, thank you.